Doug Black. I'm editor-in-chief of Inside HPC. And today we're talking with two members of the Dell Technologies HPC Community. They are Garima Kochbar and Michael Pittaro. They're both distinguished engineers in Dell's HPC and AI Innovation Lab, where they work with customers to develop and integrate customer-centric solutions based on their unique challenges. This means Garima and Michael are both at the leading edge of using the latest HPC, AI, and data analytics techniques in real-world application workloads. So Garima, let's start with you. Where are your particular areas of expertise, and where do you see your customers having a particular need lately?
Hi, Doug. My focus is on high-performance computing. So in terms of area of expertise within high-performance computing, I recently focused more on the CPU performance architecture and optimizations for CPU-centric workloads. You asked what our customers ask from us, what are they looking to see from us? So specifically, the top two things that I hear customers ask us about are making sense of the huge landscape of options available to them. There's a lot of different options in the HPC world right now from an infrastructure point of view in terms of system design, and look to us to kind of demystify or to break down, what is this that I'm hearing and what does it actually mean? What is the lab's experience with this? Do you have measured data, and can you quantify for us all these different aspects of technology, whether it's in accelerators or CPU or networking, file systems, storage, middleware, and software? What does this mean for me? So that's the first thing that we hear folks talk to us about. And then the second piece is, how do I optimize my system? And that could mean optimizing the configuration itself, optimizing your BIOS, your middleware, your compiler options, and how do I make this work optimally and ideally for my workflow? And that workflow includes not just the computation aspect of it, but clearly a lot of the I/O piece as well. And so that involves making sense of all that data. And that's where our collaboration with Mike's team comes in.
Okay, well, great. So Michael, again, tell us about where your particular areas of expertise lie, and what are some of the key challenges you've worked on with customers of late?
So hi, Doug.
Hi.
So my area of expertise is generally on the data and the compute platforms. So I guess what we would typically call big data, although it's not all big data. But a lot of my job is to understand what the customers have for data, and then try to help them both map that to the current generation infrastructure, help them plan for the future. There's a lead time on this. And then on the back end, I work with the server and storage teams to make sure that we're planning for the future in terms of some of the challenges the customers are seeing. In terms of the, the current challenges, scale is still one. Customers have a lot of data, and it's still pretty fragmented. They have multiple systems. So the whole problem of getting that data integrated and ready for analytics is an ongoing challenge for our customers. The other thing we're seeing is there's a lot more uptake in the analysis of the data. For a while there, people were just gathering data and kind of scooping it all into one place. Now they're really starting to analyze it. We're seeing a lot more compute intensive processing. It's not just data that we look at once in a while. So they're trying to run machine learning algorithms. They're using deep learning, what we normally call AI these days. And they're hitting a lot of challenges trying to scale the storage of the data and figure out how to do the compute work. So there's really that intersection between, okay, we need to get the data to the teams that want to analyze it. And it's just, there's this on long-term saying that data's heavy. You can't just sling it around. So a lot of customers are dealing with both the scale and the understanding that they can't just make snapshots, move it to a workstation, do some development on it, and then push it back. So those are the big challenges we're dealing right now. It's just the scale and managing compute and storage as two different domains, because they really are.
Okay, so you all are really at that leading edge. A lot of blood, sweat, and tears there, and really struggling with helping to wrestle
Well,
these solutions into place. So, in the industry, I've always felt it's very common for the vendors, the media, and the industry analysts to be pretty significantly out ahead of the actual end users in terms of the technology. While the customers are trying to digest and internalize technology that's available to them, the media analysts and vendors are already talking about the next thing to come. So could the innovation lab sort of be seen as a bridge between the two? You know what's coming, but you also have expertise in using what's out there in a way that accommodates in advance, if you will, or anticipates the technology to come. Garima, let's start with you.
That's absolutely right. So that's a key role that we play. I said that a lot of our customers, our sales teams will come to us saying, what is the innovation lab's experience? Hey, Doug, could you go ask the innovation lab what they've seen? So that's precisely where we come in terms of, technology that's right around the corner, to see if it actually lives up to its promise, if it's easy to use, or if it's so complicated that you need to ensure that the people using it at this time are aware of the rough corners around it. And then what can we do as engineers at Dell Technologies, along with all our partners and collaborators as well, what can we do to make that more consumable by more and more people? So that's one piece of what we do. And then the second piece of it is, of course, looking at what's further down the road, to help give it direction, to define requirements, and to keep playing with early prototype versions so that we can get the technology and how these different pieces work together. We can solve that problem from a customer centric point of view. So, like, specifically as an example, in the healthcare space, there's conversations with hospital systems, because they have a lot of data that, as you would expect them to have, but it's in very many disparate data sources, and locked into not just different hospitals themselves, but in different hospital departments themselves. And so in an ideal world, you want all these disparate data sources to be able to talk to each other, and you want an overarching platform on the top where you can glean patient information at a single glance, and draw correlations and patterns, and do some early intervention treatments or recommendations. So that's one real example of what we're looking at and where we're trying to work with specific customers. Another piece that we've already done, and you might have seen this case study, as might have many of your viewers as well, is work that we've done in the fraud prevention place with financial services industry. So another place where there's a lot of data, there's need for computation, and like Mike said, the more that you can do in putting these things together, the better outcomes and the better insight you can get. It's not enough to just have that data, it's what can you do with it. So, we think of HPC as, traditional simulation modeling, and that, of course, is something that exists. We continue to, and we do a lot of work there. But these are some of the additional areas where our collaboration with our data analytics team really benefits us to understand the exact customer problem and where we can add value to help them, work through their challenges.
Okay, great. And Michael, how about you over on the data analytics side?
So it's interesting because you mentioned blood, sweat, and tears, and that falls on our shoulders. Our customers, they generally know what they want to do. They have a good feel, especially the bleeding edge customers. They know what problem they need to solve. They're asking us, how do I solve it? And a simple answer like install this software is not what they're looking for. They want to understand how do they build out these environments so that they can share this data, how they can analyze it. And there are low-level details in there. I mean, it's not just storage. You've got to have high-performance storage. You need to have the bandwidth to access it. Now that compute has sped up, it's becoming more of a challenge because your storage is possibly not on the same machine or just doesn't fit. So you start getting into network fabrics. You start getting into advanced networking technologies. So they're looking for guidance on how do you do this. And really my job is to figure out from what they've described as the problem, how do we map that down? What infrastructure do they need? How should it be configured? Planning for the future. You can't refresh this stuff. The systems are so big that you can't refresh this stuff every year. You really have to have a slightly longer time frame just to let you grow over time. So those are some of the big challenges, but it really boils down to how do I do it? And then like Garima, looking at the trends a little further out, what we're looking at for data management, we're seeing an emerging trend towards data ecosystems within a company where the data may not all be in one place. It will actually be silos. And how do you become more of a data provider to other teams within the company so that they can consume that data and get some value out of it? So overall, I mean, it's an interesting convergence.
Yeah, that making all the more data you have, obviously, the more effective your AI workloads are. So tell us a little bit about your backgrounds. How long have you been involved in advanced technologies and how you arrived at the Innovation Lab? Garima, let's start with you.
I've been at Dell over 16 years now, and I've been part of the HPC engineering team this whole time. I used to joke that I've sat at the same desk for the longest time. So if you had a time-lapse video, you would just see me there all the time. Of course, it's different now. I'm in a COVID environment. I'm working out of home. So this is a huge change for me. It's a different desk. My background is in high performance computing. That's what I did my master's in. And so I was super lucky because when I came to Dell, I could understand 20% of the acronyms in my first week, right? You start a new job, typically you've got to first unravel what the lingo is. But because of my education background in HPC, that was the easy part for me. And the part that I love about Dell and about HPC, and the reason I've been doing this for so long is the field is so wide and the field is so deep that every few years my focus area changes and I'm like the new kid, who's got so much learning to do. And then the other amazing part about our role is that unlike most engineers in the tech industry, Mike and I have the unique privilege that we get to interact with customers on a very regular weekly basis. So while we sit deep inside engineering and work on future products and keep an eye on future technologies and so on, like Mike described, we also get to talk to people to understand their immediate pain points, and that helps us better inform our work and our decisions. And the material that we generate, the white papers that we write, the blogs that we put out, so that we're solving real problems. Anything that I'm doing in the lab is only useful if it's useful to somebody else. And so with that, that's the goal, and that's the fun part of working in the innovation lab.
Great. Michael, how about you? Your background and how you got to the lab?
Interesting. It's been an interesting path. So I've been at Dell now 7.5 years, I think going on 8. I originally joined Dell to work on OpenStack. We had a huge effort around OpenStack. I developed the original OpenStack reference architecture. And then somebody looked at my resume and kind of tapped me on the shoulder and said, so we got this big data thing going on. Would you like to start working on big data? Hadoop, our customers are asking about Hadoop. So I ended up transitioning over and working on a lot of the big data architectures, primarily Hadoop, which we've been doing for a long time now. It's interesting. I'm a hardware guy by training. My education background was hardware. I started off doing low-level microprocessor programming and chip testing. Figured out I was better at software than the hardware, and ended up in the HPC industry doing software optimization back when compilers didn't do the work for us. And early in my career, I had no interest in data whatsoever. Just wasn't my thing. I was kind of a number crunching, bit twiddling guy. I started writing some financial forecasting software and discovered that in order to forecast, you need the history. So that got me into the data warehousing business. And I've been in data warehousing since the late 1990s, pretty much dealing with databases and large scale data systems. I think I put my first data warehouse in production in 1996. And what's interesting here is, when we started off, the big data team was really just dealing with Hadoop for our customers. And we weren't really working with the HPC team, right? Because the HPC team was busy doing finite element analysis, computational fluid dynamics. Literally over the past couple of years, it's like where you look at the architectures, they're the same. The hardware architectures are very similar, and now you've got this thing where all these data folks are trying to do compute. So it's really interesting to be in the lab and see a Hadoop cluster being used for some analytics, and then seeing companion clusters being used for all the training work. As you start training these models and iterating around them, it's really an interesting environment.
Okay, great stuff. So where you work now, you're in the gap, I guess you could say, between what customers are doing with existing products and product development for next generation technology. Another venue where you're doing that, being involved in the greater world, is at the gatherings of the Dell Technologies HPC Community. Garima, start off, tell us about the value you see in those meetings.
That's a really good question, Doug. And I think that the value of those community meetings is even more clear and even more stark now that we're in a pandemic, and any interaction is so staged with scheduled video calls, and there's no organic discussions. And so that really brings to the forefront the value of that sort of community. So the Dell HPC community meeting, we started several years back, and the group meets 3 times a year in different locations. So one meeting is in Round Rock in Austin, Texas at Dell headquarters. The other one's at the Supercomputing conference, and the third one's at ISE in Europe. And it really allows for that discussion between different vendors, partners, customers, everybody working in the high-tech space, the HPC AI data analytics space, and working on it from different angles. So discussions and presentations around, hey, this is a problem that I encountered, and this is how I solved it. I wanted to share this in case this is useful to you. And also, this is the stuff that I tried that didn't work at all. So here's information for you. So that maybe you have a different starting point, plus if you have any feedback for me. And so there's absolutely no doubt that sort of collaboration and that community is so useful for all of us. And the community participation, even after we have had to go online with a meeting a week, has been really incredible, and we're really grateful for that connection.
Okay. Michael, how about you? Your perspective.
So it's been interesting because I've been much more involved in the analytics community. The analytics conferences, a lot of the local meetings, and the problems they're solving in a lot of discussions are very similar to the HPC community. In a lot of ways. I don't think you don't have Linpack at the bottom, but you have all these open source libraries that are a common ground. And one of the things we've learned as we started working in the lab and collaborating is this is kind of the same problem in a different flavor. So there's a lot of overlap, but they're really separate communities right now, and we're starting to foster a lot more collaboration between those. What's a little different in the analytics world is there's a lot of collaboration on the infrastructure, but and some of the libraries, but they don't talk a lot about the algorithms. Because that's their secret sauce. The AI and machine learning models are literally the products for a lot of these companies. So they can't be too open about that, but they do talk about techniques and some of the work they're doing. And one of the things we're seeing in terms of that is, when we talk to customers, like take the automotive industry, So they're traditional HPC users. They're doing mechanical engineering. They're doing product design. They do aerodynamic study. A lot of that is now simulation. You no longer build prototypes until you're pretty sure they're going to work. But on the other hand, every car has hundreds of microprocessors and microcontrollers in it. They're collecting telemetry. They need BIOS updates and things like that. And the car manufacturers are collecting that data. And historically, it's been a different team. But now that data is being collected, they start analyzing it. And they're looking at drive patterns. They look at customer activity. But in the broad sense, that problem is starting to become, it's currently a petascale problem. If you look at autonomous driving and you start looking at those challenges, it's heavy compute, it's heavy storage, it's becoming an exascale problem. It's exactly the same problem the HPC teams have. So, bridging those two communities is going to be really important as we start going forward in the lab and getting people talking about those things in the same room, because there's a lot of expertise in both of those fields that is really silent. This is the problem people say with the data, but it's communities as well. So those are some of the things we're starting to look into, and I'm getting much more involved in now.
Okay, well, great stuff. You're both doing great work. Thanks so much for your time today. It was great to be with you.